All right, so we've looked at sine and cosine, so you can bet this one is about tangent, right? So in this example, we have a guy wire that's supporting a cell phone tower on a flat roof, and the wire is attached 75 feet above the roof, and the wire is anchored 75 feet from the base of the tower. So let's draw what that looks like. So here's our tower, and then we have this guy wire coming up to it. And so let's say that, no, I don't know. Let's say this is the roof, and the guy wire is 75 feet. It's attached 75 feet up, right? So you can see this triangle here. I don't know how good my triangle is, but something like that. All right, there's our guy wire, and it's attached 75 feet out from the base of the tower. Okay. And we want to know what angle does the wire make with the roof. So we want to know an angle. All right. So it sounds like a job for an inverse trig function. Okay. So again, we're gonna look at the scale model of this on the unit circle. All right. So you can see if I just scale everything down, um, it's basically it's a 45 45 90 triangle. It's an isosceles right triangle. You could probably do this without without the unit circle. But on the unit circle, it would look something like this. We'd have square root 2 over 2, square root 2 over 2, and a radius of 1. Okay? So we know that the angle is 45 degrees, or pi over 4, 45 degrees. All right, so what we're doing is we're looking for the angle that gives a tangent of 1, right? Because the tangent here, because the tangent is sine over cosine, right? So the sine is square root 2 over 2, the cosine is square root 2 over 2. If you take the ratio of those, the sine over cosine, you get 1. All right, and the tangent inverse of 1 gives us our angle. Okay, so now we've introduced the inverse tangent, and we know that that angle is 45 degrees, either from, oops, not 40, 45 degrees based on our unit circle, or just the knowledge that this has to be an isosceles right triangle because the two sides are equal, right? This is a right triangle. All right, so let's take a look at the inverse tangent function. All right, so there's my tangent function. I did the same thing as I did in the other for cosine and for sine, as I took the picture of the tangent function, this y equals tangent of theta. So this is my y-axis, this is my theta axis, and then I flipped it in two directions. I flipped it vertically and horizontally, so that my axes are flipped. So this is now my theta axis, and this is now my y-axis. Okay, so the input becomes the output. The output becomes the input. All right. So again, I have a problem. If I have a tangent of say square root 2 over 2, right? So I don't know where that is. Let's say square root 2 over 2 is about there. I have more than one angle that gives me that tangent value. All right. So I have a problem because this is not a function unless I restrict the range again. And I want to restrict the range so that I can put in any tangent value and get a single output, right? Because a function has to have only one output for every input. If you put something into your calculator, you just want to get one thing out. You don't want to get multiple angles out and then have to figure out which one is right. So it's only going to give you one output. And so we're going to restrict the range to one cycle of the tangent, right? So we're just going to restrict the range to the same thing that we did for the sine. It's going to be between pi over 2 and minus pi over 2. Okay, that'll just restrict it to one cycle of the tangent. All right. So and that way we can put in any tangent we want and we'll get a single angle out. If we just restrict the angle or restrict the range, the output, which is the angle, to between minus pi over 2 and pi over 2. All right, so let's summarize all of that. So the tangent inverse is also called the arctangent, just like the other ones. But in this book, we're going to primarily use this -1 superscript to indicate the inverse tangent. So the inverse tangent of y is the angle. Again, the output is the angle. The output is the angle. And the angle is between minus pi over 2 and pi over 2. All right? So this is just saying it a little different way, but again, the output, which is the angle, is always between minus pi over 2 and pi over 2. All right, domain of the function. Now the domain, if you think about tangent can take on, the output of tangent can take on any value, any real value, any real number, right? Between minus infinity and positive infinity. And so the output of tangent becomes the domain, the input of inverse tangent. Okay, so this is inverse tangent. So the domain is all real numbers, all real numbers. Okay. But we're restricting the range to between minus pi over 2 and pi over 2. Okay, that's our angle. The angle is always going to be between minus pi over 2 and pi over 2. All right, I will meet you in the next video.